We have 4x. Number 1 is 4x minus y equals 6. In order to find the slope and the y-intercept, your equation has to be in slope-intercept form. You can't just go, oh, this thing's attached to x, so it has to be the slope, and there's a constant, so it has to be my y-intercept.
Wait.
It doesn't work that way.
Why can't you do it that way?
Because the whole reason that it works out, the slope-intercept form, is because if you think of it, when you have an equation in slope-intercept form, then if x is 0, this term goes away, so y is that. That's why that's our y-intercept. If we have the constant somewhere else in the problem, not as being the only thing added to x, it's not necessarily going to be our y-intercept. Okay? Our slope is our slope because it's what's being multiplied times x in order to equal y. But if you have, for instance, question number 2 where it has like 3x plus 2y equals 8, well, if I multiply x times 3, it's not going to give me y, it's going to give me 2y. So it's not a direct relationship between the change in x and the change in y. So it has to be in slope-intercept form, or else those numbers don't mean anything.
Is that why it's called slope-intercept form, because it has slope and intercept?
Yes. Amazing, huh? All right. So your first step has to be to put the equation in slope-intercept form, which means you're solving for y, which once again you spent at least 2 days working on that during the week I was gone. I put
That was hard, because she didn't teach anything.
but okay. All right, guys. I taught it, and you had an IXL assignment on it. And the nice thing about IXL is if you miss it, what follows that? An explanation. Guys, now, solving for y is simply a matter of getting rid of everything that's with y. So the first thing I need to get rid of, in this case, would be the thing that's with y, which in this case we have.
Wait, one.
No, we have 4x is with y.
Right. To get y by itself, I need to get rid of
4x.
the 4x, because that's what's on the same side of the equation as y. So, since it's a positive 4x, I'm going to subtract 4x.
She told us to divide by 4x.
Yeah, she did. Who did?
Well, maybe you should follow the video then.
Struggle with little.
Alright. Guys, subtracting by 4x, we are left with negative y, or you can think of it as negative 1y if you prefer, equals negative 4x plus 6. Now, from here, to find out what y is, what else do I need to do?
You need to divide by negative 1.
So I get y on this side, and on the other side, now remember you have to divide this by negative 1, but also that. Both terms on the other side have to be divided. It's just like distributive property with multiplication, only it's distributive property with division. So, negative 4 divided by negative 1. Yes, you can multiply by negative 1. It's the same exact process. So, if I divide negative 4 by negative 1, I get positive 4x. If I divide positive 6 by negative 1, I get negative 6. So my equation in slope-intercept form is y equals 4x minus 6, which means now my slope is 4 and my y-intercept is negative 6. All right. Other questions? Cole? Number 7. So back to graphing.
That one's easy.
Okay. All right. For number 7, our equation is y equals -1/2 x. Guys, y'all are being too loud. And by too loud, I mean you're talking in general because I'm teaching right now. So really, conversation should be at a complete standstill. Now, this one's already in slope-intercept form. So all we have to do is pick out our y-intercept, which is -4, and our slope, which is -1/2. The y-intercept tells us where we start, so we're going to start 4 points down. So from the origin, we count 1, 2, 3, 4 down on our y-axis. And then our slope is -1/2. So you can either think of that as a rise of -1 and a run of +2, or a rise of +1 and a run of -2. The important thing to know is as we go to the right, it should be going downward. Okay? So, if I want to think of it as a rise of 1, then that means my run's going to be -2. So that would give me this point. Or if I want to think of it as a negative rise, then my run would be +2, which would give me that point. Either way we go, we get the same exact line.
I messed it up at the first point that you did was rise over 1. I got 2 below.
You got what?
I got 2 below the second point that you made. So the y-intercept is your starting point, which is on the y-axis.
Right.
I thought. I actually
Yeah.
did both of them negative and ended up
Yeah. Then that would give you a positive slope. If you do negative over a negative, negative divided by negative is positive, and you'll end up with positive slope. And remember, a good thing to do, last thing to do, is double check negative slope. Does this line have a negative slope?
Yes.
Okay, because most of the time, most people can look at a line and pretty clearly say, okay, negative slope, positive slope. But sometimes you'll get caught up in the counting and, oh, I'm going down and over, and you won't think about the fact that, oh, hey, I'm making it a positive slope and it's really supposed to be negative. If it goes, just think, the way we read left to right. If it's going up, the way we look at it, then it's positive. If it's going down, the way we read is negative. All right. Let's see. Any other questions? Jake? Number 4. This one we have a slope of 3/4 and a y-intercept of -3. So if we start with all right, so let's say I have this line, and here on this one, they're just telling us our slope. Did we say 4? Is that the one, Jake?
Yes.
Okay. So we're given that our slope is 3/4 and our y-intercept is -3. So we always want to start by graphing our y-intercept first. Our y-intercept is
It's -3.
3 below, so -3. Graph that point. Our slope is directions. It's telling us from our first point, our y-intercept, we're going to rise 3 and run 4. And it's positive, so I'm going to be going up and to the right. So rise 3, 1, 2, 3, run 4, 1, 2, 3, 4. That's the second point that's on our line. Or again, I could think of it as rising -3 and running -4, and I get this point. And if you look, it doesn't matter because both points are on the exact same line, right? So whether you think of your positive rise as being a negative number divided by a negative or a positive divided by positive, either way, it'll put them on the exact same line. So that would be a line that has a slope of 3/4 and a y-intercept of -3. And since we just did writing an equation, and what you're going to be doing tonight is writing an equation, if I wanted to write an equation for that line, what would be the equation for the line in question number 4?
Y is equal to 3/4 x minus 3.
Yeah, exactly. So what you're going to be doing tonight, watching the video on, is how to write an equation given the slope and y-intercept, like in question number 4. We could write an equation for it, or I could give you a graph and you can find your slope and y-intercept from the graph and do the equation. So there's a few different ways that you can write equations given the slope and y-intercept. Let's see, any other questions on homework? Stanton?
Number 6.
Number 6. This one has a slope of 1 and a y-intercept of 5. So what do I need to do first?
Need to go up 5.
All right. So from the middle, I'm going to go up 1, 2, 3, 4, 5. So there's my first point, where y equals 5. All right. Then what do I do from there? Number 6.
You go up 1 and right 1.
Right. My slope is 1, which 1 is the same thing as 1 over 1. So I rise 1, run 1, both positive, so up and to the right, or down and to the left. Either way will give me the exact same line.
Is the fraction with a 1 of it a 1?
Is what now?
Is it like a 1 or not?
No, there's not really such thing as a 1. So that would be the equation. That would be the line. What would be the equation for the line in number 6? Who can tell me the equation for number 6?
I know.
Let's see, Alex.
Y equals 1x plus 5.
Good. Or we can simplify that to,
Y equals x plus 5.
right. The 1 is actually not necessary. So, all right. Any other questions?
Could you do the 2-word problems? Because I'm still kind of confused on them.
All right. So it's actually really just one word problem, but all right. So number 10 says that a person who weighs 150 pounds burns about 320 calories per hour, guys. So on our graph, obviously to draw a graph that goes all the way up to 1,500 as a starting point, you don't want to go up by every 1 because that would be a really, really huge graph. So if you'll look on our graph, the values are listed in thousands. So where it says 1, it really means 1,000. Where it says 2, that's 2,000, 3,000, 4,000, 5,000, and so on. Now, the time walking in hours, on the other hand, we don't really need to count by multiple hours. We're just going to number those. That's 1 hour, 2 hours, 3 hours, 4, 5, 6, 7, 8, and so on. Now, we have the equation y equals 320x plus 1,500, meaning Our y-intercept is 1,500. And our slope is 320 over 1, right? It's a whole number, it's over 1. So, starting with our y-intercept, because that's always where we start. Remember, these are in thousands, so this is 1,000. This is
2.
which means 1,500 would be right in the middle, right? So, this point right here is 1,500, which is our y-intercept. Now, our slope is 320 over 1. So I'm going to rise 320 and run 1. Now, again, how much is this?
That is, that's, wait, what are you looking at? Oh, that's 500.
That's 500, right? Each of these, since there's numbered every 1,000, but there's a space in between, each block is 500. So if I'm rising from here 320, that means I'm going to go
About half.
a little over halfway, right? This is 500, 250 be exactly in the middle, so 320 somewhere around here. And then run
Estimation.
1. So that puts our next point somewhere around there. Again, this is approximate. It's not going to be exact because you can't be exact on a graph that counts up by 320s and you're numbering every 500.
You can be
Okay.
more exact than you can with other things. Like
For 2, we have to rise another 320. So from this point, 1,820. If you add another, it gets it up to 2,100 and something would be the value. So it's going to be up here somewhere. And, of course, run another one. So it's going to be somewhere along there. And, of course, we know that those 3 points should form a line.
Is it bad that I labeled every single point?
One thing that's unique about this line versus the other ones is that this one doesn't have this. Why do I not have this?
Because you start with a number. And you move up. Like you can't like you have like a starting it. You can't. You have a starting number. It's hard.
What are these?
Hours.
Hours. So what is this?
That's if you like.
That's if you walked for -1 hour. Does that make sense?
I just walked for negative
No.
1 second.
Okay, there are some things you can have negative amounts of. Time is not one of them. Okay? So this graph, you don't need to include anything beyond the 0 on this side because obviously it doesn't have any meaning on this side. So this line extends infinitely in that way, but it stops at 0 because really this is meaningless. All right, and then when it asks you to interpret for number 11, they want you to realize this is our rate of change. It's what's happening. As each hour passes, 320 is how it rises. That is the starting point.